All right, let's dive right into this explainer. Today, we're going to master C++ exception handling so you can absolutely crush your upcoming assignments and exams. We're breaking down exactly how to keep your code from crashing when the unexpected inevitably happens. Here's our roadmap for today. We'll start with errors and exception basics, move into the core try, catch, throw syntax, and then look at handling multiple exceptions. After that, we'll cover C++ standard exceptions, creating custom exception classes, and wrap it all up with an essential exam recap. Okay, Section 1, Errors and Exception Basics. Let's make sure we understand exactly what we're dealing with. Now, a crucial point for your exam is distinguishing between the two main types of errors. On one hand, you've got compile time errors. Think of these as your classic syntax mistakes, maybe missing library imports or bad class references. The good news? The compiler catches these early, way before the program even runs. But on the other hand, we have runtime errors. These are your exceptions. These sneaky guys occur right in the middle of execution and just cause your program to crash out of nowhere. You literally can't eliminate runtime exceptions completely, but unlike compile time errors, you can actually prepare a fallback plan to stop your program from completely dying. So what exactly is an exception? Technically, it's an unwanted runtime event that hinders normal execution. But honestly, just think of an exception like getting a flat tire on a road trip. You can't prevent that random nail on the road from puncturing your tire, right? But exception handling, that's the spare tire in your trunk. It lets you swap it out and keep driving gracefully instead of just abandoning your car on the side of the highway. Moving right along to Section 2, try, catch, throw syntax. Let's look at the core syntax. C++ exception handling is built on three main keywords, and the execution flow here is strictly linear. First step is try. You basically enclose your dangerous, error-prone code inside a try block. Second is throw. If a problem actually occurs, your program throws an exception. It's essentially sending up a distress flare. And third is catch. This block catches that flare and handles the error. If everything runs normally, the entire try block finishes perfectly. But if an error triggers that throw keyword, control instantly jumps straight to the catch block. And this brilliant example illustrates that basic syntax in action. Check out this code handling a division by 0. If our denominator variable, b, equals 0, we throw a string message, division by 0 not possible. The exact moment that throw happens, boom, we instantly skip the division math entirely and jump straight down to print the error via the catch block. Now, you might be wondering, and this is a very common exam question, why don't we just use standard if-else statements? Well, the answer is that try-catch cleanly separates your main logic from your error handling. The problem with relying only on if-else is it creates a ton of unnecessary, messy code, and it really relies on you predicting exactly when and where an error will happen. Try-catch, on the other hand, simply breaks and moves to the catch block whenever the exception occurs, no matter where it happens inside that try block. All right, Section 3, handling multiple exceptions. Let's see how we handle various different errors at once. You can absolutely have multiple throw statements sitting inside a single try block. Depending on the specific error condition, which we're checking here by the value of a, the program can send out entirely different data types. It could be an integer, a character a, or a decimal 1.5. And because you can throw different types, you can stack multiple catch blocks right below it to handle each specific type individually. But wait, here is a massive gotcha that you might trip over on an assignment. Implicit type conversion does not happen for primitive types in catch blocks. Let me repeat that. If you throw a character like a and just assume it's going to be caught by an integer catch block, your program is going to crash. C++ requires an absolute, exact type match for primitive exceptions. No exceptions, pun intended. So to prevent your application from totally crashing due to an unmatched type, you should always include a generalized catch block at the very bottom of your catch chains. The syntax is super simple. Just catch, parentheses, and 3 dots. It acts as the ultimate default safety net to catch literally anything that slipped through your specific filters. Let's move to Section 4, C++ standard exceptions. These are the built-in C++ errors. This is a fantastic blueprint of the std.exception parent class and all its children. The C++ standard library has this built-in hierarchy, and it's categorized broadly into logic errors, which are, theoretically detectable just by reading the code, and runtime errors. For your exam, you are definitely going to want to memorize these highly testable standard exceptions. First up, remember that bad alloc happens when the new operator fails, like if you run out of memory trying to declare some massive array. Then there's out of range, your classic bounds violation, usually thrown by the .at method in a vector or string. Moving down, we have invalid argument for bad math inputs, and finally, bad cast for failed dynamic casts. Now, what's really interesting here is the what method. This is a public virtual function provided by that base exception class. Whenever you catch one of these standard exceptions by reference, you can just call x.what inside your catch block. This extracts a super clean, readable C-style string that describes exactly what went wrong. Next up, Section 5, Custom Exceptions and Classes. Let's talk about user-defined errors. Sometimes standard errors just aren't specific enough for your assignment. The good news? You can easily create your own. You simply include the exception header, create a new class that inherits from public exception, and overwrite that virtual what function we literally just talked about so it returns your own custom error message. This is how you inject your specific domain logic directly into the error handling. And what's really cool about this is you aren't limited to throwing basic variables. You can actually instantiate and throw entire custom class objects, like the Demo1 and Demo2 classes you see right here. Then you just catch them by their specific class type in the catch blocks. It's an incredibly powerful way to pass complex error states around your architecture. Another brilliant programming pattern is putting a throw statement directly inside your class constructor. Think about it. If someone passes invalid parameters into an object creation, throwing an error immediately prevents the object from being fully created with garbage data. That saves a ton of memory overhead compared to a clunky if-else setup where a broken object is still taking up space in memory. All right, final stretch. Section 6, Essential Exam Recap. Let's go over our essential checklist. Here is your mental blueprint, the absolute golden rules. 1. Wrap the dangerous code in a try block. 2. Allow multiple throw statements for different situations. 3. Stack your catch blocks to handle different data types separately. And 4. Always catch standard exceptions by reference so you can properly utilize that .what method. Please lock this strict syntax rule into your brain for your exams because it's a classic trick question. Absolutely no code can be placed between the closing brace of a try block and the opening brace of the first catch block. I mean it. If you put even a single innocent print statement in between them, your entire code will fail to compile. So, the crucial takeaway is this. You can never completely eliminate exceptional circumstances in the real world. When your users inevitably run out of memory or randomly unplug a device, is your program going to abruptly crash, or have you written the exception handling to let them exit gracefully? Really ask yourself, is your code robust enough to handle the unexpected? Thanks for tuning into this explainer. Best of luck on your exams, and as always, keep your code crash-free.